All right, thank you for tuning into the video on qualitative graphs. Qualitative graphs deal with the quality of something, and so that means we're going to have a story about it. We're going to have more than just numbers about a graph. So first off, we're going to follow our steps and tell the story of the graph of the speed of a car. So right here, we notice that the car is increasing its speed. So we could say, we'll say Miss Callahan is driving her car. She left her house at a increasing speed. Okay, so I am leaving my house and I am increasing my speed. This horizontal line right here means the speed did not change. So it doesn't mean that I stopped the car, it just means that I was driving at a constant speed. So I could say then she reached a constant speed. If we wanted to put some mileage in there, we could probably put like 30 miles an hour. And then we had a dramatic drop. So that means you're going a certain speed and then your speed completely stopped. So that would be an example of someone hitting the brakes. So I could say a squirrel ran in front of the car. So Miss Callahan had to slam on the brakes. So that would be a wonderful paragraph sentence of a story of this graph. So as long as you talk about the car increasing speed at a constant rate, as long as you talk about the speed of the car going the same miles per hour, and then this drastic drop would mean that you are slamming the brakes. So that would be how you do these problems. Second problem, we have distance from home, and then we've got a time. So we are leaving home, so we've got our distance going away from home. So let's say we want to go to Taco Bell. So Miss Callahan again, because she loves Taco Bell. Just kidding, I hate it. Miss Callahan is hungry. She decided to leave home and walk to Sonic. I could walk to Sonic from my house. Alright, so here would be me walking pretty slowly to get to Sonic. So right here, noticing my distance is not going up or down. So this would be an example of Ms. Callahan sitting somewhere eating Sonic. She arrived at Sonic and decided to eat her corn dog. And then Ms. Callahan is going to go back home because that's where we started. We started at home down here. So if I go back down to this x-axis, it means I'm arriving back home. And notice I went a little quicker home. So maybe I tried to run off that corn dog. So to get some exercise, she decided to run back home. Okay, so you've got Miss Callahan leaving from home, staying somewhere for a period of time, and then returning back home at a faster rate. Okay, so these are examples of qualitative graphs and writing lovely stories from them. Make sure you capitalize your letters and your popular places, your public places. Put some commas in there and some periods, punctuation, because we like correct grammar. All right, so what I want you guys to do is I want you to try these two on your own. Notice we have a speed graph and we have a distance from school graph, so kind of like the first two we talked about. I would write in pencil because if you make a mistake, you're going to need to erase it. But I want you to try these two scenarios. So read the description and give me your best graph. So it should look something like this, a line graph with things connected, okay? All right, so press pause and try those two on your own. So here is what you should have gotten something along these lines for the speed of a graph, and it's okay if you got this wrong because speed's probably a difficult problem. So real quick, if you are stopping speed, it's basically a straight line down. So you're somewhere and then you stopped, okay? So if you're ever stopping, that's where you drop the line all the way back down, because down here, this x-axis is like 0 miles per hour. Maybe you walk a max speed of 5 miles an hour, okay? So when dealing with speed and you're stopping, it drops back down. While when you're dealing with distance and you're stopping, it's a horizontal line. So let's take a look at this. So you've got Abby walking in class very fast. So I have a steep line here in black. She's going to slow down, but she's still moving. So she's got like a little less so steep of a line in here in red because the hallways are crowded. She stops at her locker for 1 minute. So she, boom, stopped here, right here for a minute. So she's not moving, okay? She begins running to class. So I have a steep line going up. Miss Hartman, who used to be a principal, shout out to Miss Hartman, stops her to discuss how amazing she's doing in class. So she was stopped for a brief minute to talk. She's going to walk to class, so not as steep as before. And then she's going to have a seat, so she is seated right here, not moving whatsoever. So if it's speed, again, when you're sitting or talking or not moving, drop it down to the x-axis and draw some lines, because time is still passing when you're not moving. Now we're going to look down here with Chico. We've got distance from school, so let's treat home down here and school would be somewhere up here. So he loves McDonald's breakfast. Chico leaves home and walks to McDonald's, as shown by this red line. He goes inside to order a McGriddle and a hash brown, which takes you a few minutes. So he's not moving distance-wise. So that's a horizontal line. His distance is staying the same. And then he's going to go to school. So he leaves, but then realizes they didn't put his hash brown back in the bag, so he has to go back to McDonald's. So I went to school, but I went back to McDonald's and waited a while to get my hash brown. So then he's walking to school. So I've got my red line going up. And then he has to stop at a crosswalk. So you've got a horizontal line waiting for the crosswalk sign to come on. Begins walking and makes it to Fulton, so he is no longer moving, okay? So it's okay if your graph isn't exactly like mine, but as long as it's going up and down kind of in the same generic area, okay? So let me know if you have any questions about distance or speed graphs. Otherwise, we'll move on. All right, so I want you to try this one up here on your own, and then we'll do this one together down here. So try this top part. I want you to determine whether graph 2 represents A or B and explain why you chose it. So please give me a complete sentence for your explanation on this one. So press pause and try it on your own. So for this example, I said graph 2 represented car B, and I said because it stopped for gas right up here, and you can see this by the horizontal line shown circled. You could have also said graph 2 is car B because it says they started out more slowly and their line is less steep. But anything along those lines would be correct. If you're not sure, let me know and raise your hand and I can come let you know if you're correct or not. But graph 2 would be car B. All right, next one we've got in order to buy Beats by Dre, which we all would love. So I've got this graph and I've got hours mowing lawns and hours that I'd have to work at McDonald's in order to buy Beats by Dre. So what does the ordered pair 0, 11 mean in the context of this problem? So when it asks for the context of this problem, that means you've got to talk about ordering Beats by Dre in some case. So the ordered pair 0, 11 would be 0 on the x-axis and 11 on the y-axis. So what does that mean? That means I would have to work 11 hours at McDonald's. So I would need to work, let me go ahead and make this smaller. 11 hours at McDonald's and no hours mowing the lawn to buy Beats headphones. Okay, so I can afford those Beats headphones if I work 11 hours at McDonald's, which is maybe true, I don't know. What does 11-0 mean in the context of this problem? 11-0 would mean 11 on the x-axis and none on the y-axis. So that would mean the same except vice versa. So let me go ahead and copy this. So I would need to work 11 hours mowing lawns and no hours at McDonald's in order to buy Beats headphones. Okay. Lastly, if Ryan chooses to mow lawns for 5 hours, how long should he work at McDonald's? So I'm going to find 5 hours on the mowing lawn side, which would be right here, and then go up. And so that would mean 6 hours working at McDonald's. So Ryan should work 6 hours at McDonald's. Okay? All right, so let me know if you have any questions interpreting that graph or describing something in the context of a problem. Otherwise, make sure you wrote complete sentences on these, okay? All right, one more page. All right, you've got John and his father participating in a 100-meter race. John started the race 4 seconds after his father began to run, and the graph provides information about how far they ran over time. So we've got John and we have his father. So I know that John got a head start because he started 4 seconds after. So write a story about who won the race and be descriptive about how the race was run. And then if 2 lines describing how each person ran were parallel, how would the graph tell you who won the race? So I want you to write a story about this graph and then answer this question down here on your own, and then we'll go over it. So press pause and go ahead and get started on that. So here's an example of my story. Again, you probably did not have my story unless you think 100% like me, so I would love to read your stories. But first off, I said that John and his father were running a 100-meter race. John gave his father a head start to be nice. John had to start off running faster to catch up to his father. So kind of make sure that you talked about how John's line was more steep, and so he was running faster. Make sure you talked about that they passed each other or they were at the same spot at 60 meters or 10 seconds. And that he came in first place and his father came in second place. I put that they finished 2 seconds apart from each other, but just as much as description that you can give about that graph. If I had 2 lines running parallel, how would you know who won the race? I said that if they are parallel, that means they're running at the same speed. And so if the graphs are parallel, it would determine who started first to see who would finish first. So if they're running the same speed, whoever started first would win that race. Okay? All right, last one. I have a graph that represents the relationship between profit and the amount of lemonades sold at a lemonade stand. And I want you to write a story about how the lemonade stand's profit is determined. So include an explanation of what is indicated when the line is below 0, when the line has crossed this horizontal axis, so what happened right here, and assume that the seller has not paid and that there is no overhead. So basically that's just you're doing a lemonade stand and this is your profit. So you're not having to pay someone to sell the lemonade. So first off, this horizontal line right here is when you break even. And so if you sell anything down here, that is the cost to sell. So if you are doing a fundraiser for a car wash, you had to go out and buy supplies. If you're doing a fundraiser for t-shirts, you had to go buy those t-shirts. So you're going to start off in the negatives, okay? So this would be your cost to sell something. Right here, you would break even, and so you've got $0. You've paid off everything that you had to pay, but you haven't made a profit yet. Anything above that would mean that you're making a profit. So you're selling some lemonade. Right here, you had a drop in your profit. So maybe it got really cold outside and no one wanted to drink lemonade. Maybe Hurricane Irma came through and you couldn't sell lemonade anymore. So this would be a price drop. So maybe lemonade is not $2 anymore, now it's 25 cents to see if you can hurry up and get rid of your lemonade. And then right there is when you're starting to see that money happen again. Okay? So a story would be, we'll say Ms. Callahan again. Ms. Callahan went to the store to buy lemons and mix to make lemonade. That is shown by the graph starting in the negatives. Okay, so here is my cost to sell right here. I started to sell some lemonade, so I made a profit. We'll say she started. We'll say one day it was really cold and no one wanted to buy lemonade. No one wanted to buy lemonade anymore. Ms. Callahan had to lower the price to sell out. So that's my lowering the price right here. And then I could talk about this line. Once the price was lowered, everyone wanted to buy lemonade. Goodness. Okay. So these are examples of qualitative graphs. And you do need to write incomplete sentences and talk about each kind of piece of the story in your own way. So that's just one story that you could have written about. Tons of stories. If you have an interesting one, let me know. Otherwise, that is qualitative graphs, and now you are more than welcome to practice. Thank you for watching.